Hi everyone, I'm Anicia. Welcome to my channel. On this channel, we cover content related to physics and building drawing. We'll also touch on some of those engineering topics that comes under the Building and Mechanical Engineering, aka BMED CXC syllabus. So today, we're going to be doing the centroid of irregular shapes, and we're going to look at it from a graphical standpoint, the graphical method. And of course, graphical method covers first and second moments of area. So come draw with me. Here we go. All right, so this is the drawing that we're going to be using today as we demonstrate the graphical method for finding the centroid of an irregular shape. So let's get drawing. So I have my layer selected object. Now, if you want to know the settings I use to create this template to get the layers and all of that, just send me a message below, comment below, and I will be sure to do a video to show you how I did that. So I have my object, select line, could have done L enter. Now base is 45, gonna get that, wow, 45. Now I'm gonna go to offset. So I'm gonna offset the different distances. I'm gonna offset the different distances to produce the drawing. So here we go. When I'm using offset, I'm going to be using the through option, because what this enables me to do is to specify the distance each time I offset, because I have different distances working within this one. So 40, and then 57, and then this is 38. So real simple, real easy. Now I'm going to draw my circle, C enter. It will be from center here, 38 radius, good. And then now I'm going to extend on this side too. And then now I start my shape. So connect from base to here and from here to here. Then I delete what's not necessary. I'm going to leave this line for a little later. You'll understand why I left that line. Delete U, and then I trim. Enter twice after I did TR there. Okay, so now I have my shape. So I'm going to just select all of this, going to move it a little distance away. Right? So this is my shape. See, it looks the same. Very good. All right, so now to our next step, we need to put this shape on an axis. So we need to establish an XX axis. So I just select line. Like I said, there are many ways that you can do what I'm doing. So if you have a better way to do it, or to you an easier way, by all means go ahead. So all right, this is now our XX. I need to change my layer. Throughout this video, I'm going to be going through different terms that are related to this concept. So first off, this shape is symmetrical. Symmetrical simply means when I drop a line in the middle here, you would recognize that whatever is on this side, it's the same thing on this side. And the dimensions would also be equal. So not just is the shape the same, but the dimensions are the same. And so this shape is symmetrical. Now, because of that fact, when we're doing this question, we don't need to replicate both sides. We just need to do one side, and then now we're using AutoCAD. So, we use the convenience. We use the convenience of AutoCAD, and we could just copy and put it on the next side, and voila, we're done. So that's, plus of AutoCAD. If we're doing this by hand, you would know the struggles. So this line now will represent our X. I'm going to put this in 0 layer, and my 0 layer represents construction line. And so here we go. So now I'm going to put in text. I'm going to select my text layer. And there we go. So I'm going to specify now my start point, which will be, zoom in a little bit here. And as you can see, my settings are already there, so the height is already 3. And rotation, of course, will be 0. X. And put over here. And I'm going to name here O, because this is the intersection of my X and Y. So I'm going to, for the beginning, just move this line back to up here. All right. So now we have our XX. O needed to put a Y up here. So for convenience, I just copy this. Turn off ortho. And put this as my Y. So there we have it. You must put it on an X base. And now you see that this line now, I keep it because you need to have a line that would represent your height. It would go to the highest point of the shape. So no matter how the shape looks, you need to have that line that goes right up to the highest point. So here now is our shape, and we have it on our X. We establish where our Y is. Because it's symmetrical, we put it in the middle. Right, we work with that. And then now this now represents our height. Good. We're now going to be offsetting some horizontal distances between this line and our XX. So I'm just going to use offset. So I'm going to specify a distance this time so that I just repeatedly offset. So these lines I'm offsetting, they represent, and I'm going to change the layer when I'm done. Didn't remember to do it before. These now are called ordinates, and I think that's the last one I'll get. So you could have used even divisions. That's a choice you can make. You could have used even divisions, or you could just put them at any convenient distance. Really doesn't matter. What you have, the lines you have will give you just exactly what you need. And if you need any greater detail, like you recognize that when you're drawing your curve, you know, you probably need a little bit more detail to get you that perfect curve, then you would just add some other lines. So it's really a random process. It can be random. Okay, so now I'm going to be using a hidden line, and I'm going to be offsetting to a distance right between these, and that line now will become our mid ordinate. So I go to offset, and this time I'm going to select layer, because if you recognize offset, what it does is it offsets to the layer of the object you are doing that duplication for. And so because I want it to come to the current layer that I selected, I do layer and do current. Now the distance will be 4. Now you have to be mindful of your lines that you have, the horizontal lines. And remember, ordinates are solid, mid ordinates are hidden detail lines. So that would make our process a little bit easier. So to get our first derived area, we're going to be starting with our ordinates. So what we do with our ordinates, and I'm going to put this back to 0. Select where the ordinate intersects with the shape and bring that up. Let me turn on ortho, make our life easier. Bring it up to the height, that line that represents the highest point. Then you bring it down to this point, which we will call the pole, right? Pole. Now, because this is going to get very pretty, there are going to be a lot of lines. Just going to change the color. Going to change the color so that it doesn't get confusing. All right, now, so after you've brought the line from the ordinate up to this parallel line, and I'm going to name it so I can have a reference, you bring it down to the point that is the pole. You are going to put a point on the same ordinate. Where this line comes back down, put a point on that same ordinate. So I'm going to name my line so I need to change these to the correct layer. And it's not in the correct color yet. That's because I made a change to the settings over there. So just do by layer and we're good to go. So now let's go point. Make sure you're putting it on the same ordinate. Right there. Now you're not seeing the line or the point. Don't worry. Just go to P-type, change the shape of it. So it was a dot. That's why you weren't seeing it. Put this to absolute unit. So what that does is the size of the point will not change regardless of the zoom of your screen. Now when it's on relative, it changes according to the zoom. So 1 seems to be just right. I don't like when it's too overpowering. So again, I just need to change this to bilayer. Good. So now we're going to go to our second one. And you just repeat this process. It's important that you do it one at a time. Don't try to do all ordinates and then you try to determine where the point should go. That's going to run you into problems. So just trace. This is where it gets tricky. So just trace the line. So it starts here, went up here, and came back right here. And you're good to go. All right, so now we have completed all of the ordinates on this side. Now remember, as I said, this is a symmetrical shape, so we don't need to go and do the same thing on the next side. So let's now see if we're going to need to put any extra points. Like I said, if you need any extra ones, you can always just put them in. So I'm going to go and select, and I'm going to be mirroring. So now I'm going to go spline, SPL. And this now, you will go to every point that you have created, and this is our first derived figure. All right, so put it in our object layer. I need to change this to bilayer. Awesome. So that is our first derived area. Don't think I need to put any other points. I think I can work with what I have. Now, because of the technicality that this can pose, I'm going to be copying these and like pulling them out so that we do not get confused. So, and I said copy because when you are producing your question, your final answer, you want to show all the work you did. So you don't want to get rid of everything. Like I said, I don't really need these lines that we used. Don't really need them. So I'm just going to get rid of them. So now we have our given shape. We have our first derived area. We're going to find the second derived area. I'm going to also be making a little copy of the given shape. So when we've gotten the second derived area, we're going to just copy and plug it here so we can have this to show how we derived the first and second figures. So now we're on this one. So we're going to repeat the same procedure, same procedure going forward. So I'll enter, and again, we're coordinate, cut shape, up to LM, and down to pole. Now that's it for this side. So again, I'm going to be selecting and mirroring. All right, so that's more or less what the second derived area looks like, but I think I spotted an error while I was going. So let me go and see to make sure all of them are placed on the correct line, all of the points. Best I check for errors now, and this is the point that I'm seeing, than later on when things have all gone wrong already. So this point connects with this point. And so this point should have been in here. Okay, so I'm going to fix it on this side as well. So going this one goes with this one. And this is another method I use to locate where the point should go. I select both lines and then just move it in. Good. So if you happen to make an error, just simply find the error, make a correction, just like I did. So this now is our second derived error. So I'm going to, again, copy it out, put it to the side. And guys, really and truly, don't be afraid to make mistakes. If you make a mistake, it's not the end of the world. Just, it's good if you can identify that you made a mistake so that you can make a correction to it. Beauty about it is noticing that there is an error. So this now is my second derived error. Right, so I'm gonna move down now my first derived area or figure. So I'm going now to label my drawing. I'm gonna move these a little bit down because I'm gonna be using the space below there. Alrighty. But for what we're gonna be doing now, we're gonna be finding the area. Gonna be finding the area of these shapes. And for that one, we're going to need to put the pole. We're gonna put the pole some distance below. So you can use a pole distance of 30, 40, or 50, or anything, any number, any value that's convenient to you, but I'm going to be using a pole distance of 30. So start line, 30. And I can just copy this and paste. All right, so that's my pole. Okay, now, recap. To get the first derived and second derived figures, we used what? Yes, we used the ordinates. However, when we want to find the area of these shapes, we need to use the mid-ordinates, because some of you may have been wondering, so what was the purpose of the mid-ordinate? We are now at that point. So when we are using ordinates, another difference, we went up. Now when we're using mid-ordinates, we come down. So I'm going to demonstrate on the given figure, and then now you can replicate. You realize it's really about replication. You're going to replicate now for the first and second derived figure. So here we go. I'm going to change this back because you know I like to use colors. It makes it easier for me to see. So here we go now. And if you're having a challenge finding it because of the hidden line, just simply use tracking to your benefit. Okay. So another aspect of finding the area of these shapes is getting your funicular polygon. Now, a funicular polygon is really just a link diagram that you obtain by drawing parallel lines from one point to another, or transferring parallel lines from one point to another. So what I'll be doing, I'm just going to be copying this line that I have here, using this as my base, and pasting it right here. So now what I will do is to trim this line, and I'm going to be trimming it above the mid-ordinate that I did. So it's gonna be above the mid-ordinate, which is right on our ordinate. So you're trimming it at the ordinate above the mid-ordinate it's coming from. I hope it don't sound too confusing. So we trim it right there. Get the gist? So it's coming from this mid-ordinate, but when you're doing your funicular polygon, you trim it at the ordinate just above its mid-ordinate. Hopefully you get it. So here we go now, line, and remember we're going from mid-ordinate this time. Down, and down to pole. Ooh, made a mistake. Undo, clip you right there, copy, and remember, do it one at a time. It's better than trying to do it all at once. You are bound to make errors. Not everybody will make errors, but I prefer to use the method that gives me more of a guarantee that I will not be making errors. So again, mid-ordinate, down to XX, down to this pole. Paste here, trim. So remember it's coming from here. This is where it's coming from. Trim at the mid-ordinate, at the ordinate, sorry, just above it. Okay, good. So this is now our funicular polygon. So now what I'll do is just put a label here for where it ends. Wow. And I'm going to name this H. Just me giving a letter. So that's where our funicular polygon is. So now to determine the area of the shape, what is done is that we find the width of the funicular polygon and we multiply it by the height of the pole. So that's how the pole comes into play. So I'm going to be using tracking, line, then TK, enter, and it will ask me for the first tracking point. So this ensures that, I get it accurate. And I press enter to start my line. And of course, I'm going to be using tracking to line up on that side. Very good. So I'm going to just move my text out of the way and move this. So this is now the area that we are going to be focusing on for our to find the area of this shape. But what we will also do is we'll have to double it because we only did one side. Hopefully you got it. So if it wasn't symmetrical, you would now need to do the area of the right side as well, using the same procedure, of course. So here we go now, text. So here we go now, text. I'm going to put area of figure 1, and that's going to be equal to, I'm a physics teacher as well, so formula is a must. So it's equal to length times width, and so this area is going to be equal to, now I didn't take the dimension, and this is times 2 because we only did half of the area. So bear that in mind. Text bilayer. So I think, no, I can't take that out as yet. So let that stay. So now I'm going to be just dimensioning this area. So you would have to show these values when you are calculating. You would have to show these values so that the person who is marking would know that you did it accurately. All right, so area now, so we can now fill in values. So area is now equal to 30 times 50 times 2. And because we're drawing in millimeters, you know it becomes millimeters. And I don't have the feature, so I use that. Like I said, I'm a physics teacher, so units are important. And it's area, so it becomes square units. So this is the area of the figure. Remember, you must multiply it by 2 in instances where you're doing a symmetrical diagram and you only focused on one side. So, like I said, the procedure is replicated for first and second derived figures. And just in case I didn't say it before, or for emphasis, remember that after you have done this process, so you've carried your line down to your base, down to your pole, and then you're copying, when you paste it, you would recognize that you're pasting it at the ordinate below, the mid ordinate it's coming from, and then you are trimming it at the ordinate above where it's coming from. So let's go again. You're pasting it, here it is. Paste it at the ordinate below, trim it at the ordinate above. All right, so now we have almost completed this question. Almost there, don't worry. So we did the area of the given figure, area of first derived, area of second derived. Now we're going to put those all into a formula so that we can get coordinates for the centroid. Now for this one, we know that the centroid is located along this y because it is symmetrical. So, going to introduce you now to the equations. All right, so now we're going to do the calculation in Word. We can copy it and paste it in AutoCAD when we're done, or when you are submitting, just ensure that you submit this portion as well. So I'm going to be inserting equation. It's much easier to work with Word for this aspect, so I usually just use Word. So I'm going to be starting off, so XX to centroid, which is also equal to y bar. So that's what y bar looks like. Is equal to, and I insert my fraction. Now, basic math, basic mathematical operation, you would recall that you can actually have factorization. So m millimeter squared as numerator and denominator, they would cancel out each other. So let me just demonstrate that. The millimeter squared cancel each other, and so when you divide, you ended up having 0.84 here, no units because it canceled, and then here would be millimeters, and so your y bar answer is also in millimeters. So pardon me, it's just the physics in me. Alrighty, so this now would be the answer. So like I said, if you do not want to import it to AutoCAD, you just ensure that you have the answer affixed to your results. So now we found where the centroid is located, and remember we also highlighted that the centroid was along, let me go back to AutoCAD. The centroid is along this point here, and so now what we're going to be doing, we're going to be locating our centroid using point, and we're going to be using tracking. So first tracking point is here, and then we say 27.36, that's what it was, right? Yeah, that's where it is. Press enter, and that is our centroid. So you must identify where your centroid is. You must, very important. Must identify where your centroid is, and then you can put a label there to ensure whoever is marking it recognize that you know what you're doing. You put your C, centroid. All right, so of course, after you have located it, you need to dimension it, because remember, we can't take any measuring instrument to your drawing, so we won't be able to tell if you did it correctly. So make sure you dimension to show us that yes, this is the height of your centroid. All right, guys, that's it. Thanks for watching. I hope this video was really helpful and you are now able to find the centroid of an irregular shape using the graphical method. Remember, you can always pause, rewatch, so that if there's any step that you missed, you can go ahead and catch that one. If this video was helpful, pass it on to somebody else. Who knows? You could help somebody who is struggling along. And of course, if you want to know when I post another video, you are gonna need to click that bell so that you'll be notified whenever I make a post. Thank you guys for watching. See you in my next video.